What if the stars were not as far away as they seem? Look up at the night sky. Pick a star. Any star. It feels impossibly distant, a cold point of light from a time long past. Our fastest rockets would take tens of thousands of years to reach even the closest one. That distance has defined us. It has kept us tethered to this small blue marble. But what if, by the year 2030, we built a machine that could fold space itself? A device that doesn't travel through space, but rather carries space along with it. What if we built a warp drive? This isn't just a question for science fiction anymore. Quick pause, like, comment, and subscribe for more deep dives. It is a question that forces us to look at everything we know, our economies, our cultures, our very identity, and wonder what would happen when the universe suddenly becomes our neighborhood. This essay is a journey into that possibility. We will not get lost in complex mathematics or dense physics. Instead, we will use simple words and everyday ideas to explore this monumental shift. We will walk through the labs where scientists are racing against the clock. We will listen to the conversations of families planning for a future no one had ever dared to imagine. We will consider the hard choices that world leaders would face. The arrival of a functional warp drive in just a few short years would be the single greatest event in human history. It would rewrite our rules, reshape our dreams forever, alter our place among the stars. The change would be profound, touching every corner of our lives. Let's be clear from the start. This is a thought experiment, a guided tour of a potential future. But it is a serious one. The fundamental ideas behind a warp drive, while hugely challenging, do not violate the known laws of physics. The concept, proposed by physicist Miguel Alcubierre, is a legitimate area of theoretical study. So, how does this magical-sounding machine actually work? Let's put aside the image of a roaring rocket engine. A warp drive is something else entirely. It is more like a cosmic surfer than a sprinter. Imagine your starship is a surfboard. Spacetime is the ocean. A rocket is like paddling furiously against the water. A warp drive, however, doesn't push the surfboard. It tells the wave underneath it where to go. The ship itself stays perfectly still, inside a bubble of flat, normal space. It is the bubble that moves. This is the core concept of the Alcubierre drive. It's a way to cheat cosmic speed limits without breaking them. To make this happen, the drive would need to do two things at once. In front of the ship, it would have to compress space-time, pulling the destination closer, like an accordion. Behind the ship, it would need to expand space-time, pushing the starting point farther away. The ship inside the bubble wouldn't feel acceleration. The coffee on your dashboard wouldn't even spill. You are not moving fast. The space around you is. From the outside, the bubble can appear faster than light. Inside, the ship still obeys all the normal rules. It's a clever loophole in Einstein's relativity, but creating it is the hard part. It would require exotic matter, material with negative mass, or negative energy density. Normal matter, like a bowling ball, makes a dent in a trampoline. Negative matter would do the opposite. It would make a bump. We haven't found any of this lying around. So scientists in our 2030 scenario would need to generate negative energy effects with quantum fields. That's the monumental breakthrough. It's not about finding a magic rock. It's about mastering the energy of empty space itself. Controlling this is an immense computational challenge. The ship's computers would need to manage unimaginable amounts of energy with perfect precision. They would constantly adjust the warp field to navigate. They would adjust it to turn. They would adjust it to slow down. A tiny miscalculation could collapse the bubble, or send the ship careening into the void. So development isn't just physics. It's a computer science problem, a material science problem, and an energy problem. It's the ultimate team sport for scientists and engineers, requiring breakthroughs on a dozen fronts. Picture a simple, colorful diagram showing a spaceship inside a bubble, with arrows indicating space contracting in front and expanding behind. If the announcement comes in 2030, the work must have started years earlier. Let's imagine the journey. Around 2025, a quiet consortium forms: university labs, private aerospace companies, funded by secretive patrons. They make a key discovery: a microscopic, fleeting negative energy field in a vacuum chamber. It lasts only a nanosecond. The data is confirmed. The race is on. Funding floods in. Governments, corporations, secrecy tightens. Remote research campuses in deserts, remote mountains. A frantic sprint begins. Teams of physicists, materials scientists, AI programmers work in parallel. One team scales up energy generation, from tiny lab effects to a field that can envelop a small probe. Another team designs exotic warp field materials, alloys, metamaterials. A third builds the AI to control the forces. There are failures, sudden energy discharges, probes vanish, risks explode, pressure mounts. Think Manhattan Project, but for exploration. The brightest minds are recruited, working under intense pressure. News leaks, science blogs, in financial reports. The public is captivated, skeptical, excited. Rumors send markets soaring or tumbling. The project becomes a global obsession, inspiration for students, anxiety for leaders. The 2030 breakthrough is thousands of small victories. The successful test, Wanderer 1, a 1-meter probe to Mars orbit and back in under a minute. Data streams back, clear and undeniable. The bubble was stable, the navigation was precise, the probe is intact. In labs worldwide, scientists weep, laugh, embrace. They had done it. They had given humanity the stars. Now begins the harder work of what to do next. Imagine a brightly lit, futuristic laboratory at night, where exhausted scientists huddle around a glowing device. It vanished from a lab in New Mexico and reappeared milliseconds later in orbit around Mars. The news flashes across screens worldwide. The world holds its breath. The age of interstellar travel has just begun. What happens next? How does humanity react when the impossibly vast cosmos suddenly fits in the palm of its hand? Let's explore the ripple effects, from the grandest scale of geopolitics to the quietest moments of personal wonder. The first and most immediate consequence of warp drive is the death of distance. Our entire perception of the world and the universe is built on how long it takes to get from one place to another. A trip to Proxima Centauri, our nearest stellar neighbour at 4.2 light-years away, would transform from a 75,000-year journey with current rocket technology to a matter of weeks. A trip to Mars would become a weekend getaway. The solar system would effectively shrink to the size of a continent. The local interstellar neighbourhood would become the size of our planet. This isn't just a quantitative change, it's a profound qualitative shift in our reality. This shrinking would redraw our economic maps. Industries would be born overnight. Imagine asteroid mining not as a distant dream, but as a practical, daily reality. A single ship could haul back enough platinum from the asteroid belt to fundamentally alter the global commodities market. Fast, cheap interplanetary cargo would become the new backbone of commerce. Companies would no longer be multinational, they would be multiplanetary. New trade routes would open up across the vast, dark sea of space. The economic center of gravity could shift away from earthbound resources toward the untapped wealth of the solar system. Politically, the world would be thrown into a state of flux. What does a border mean when you can cross a planet in minutes or a solar system in days? Nations with warp capability would possess an incredible strategic advantage, able to move resources, able to move personnel, able to move military assets. The old balance of power, based on navies, based on air forces, would become obsolete. A new space race would begin, but this time the stakes would be infinitely higher. International law would need to be rewritten from scratch to handle questions of territorial claims on moons and planets, traffic control in crowded orbits, regulation of this powerful new technology. For everyday people, the mental map of their lives would expand beyond all previous limits. The idea of home would change. A family could have a parent working on a research station on Titan, children studying on Earth, grandparents retired in a low-gravity habitat on the Moon, all while staying connected by weekly visits. The sky would no longer be a limit but a highway. This would ignite a new age of exploration, not by a select few astronauts, but potentially by millions of ordinary people. The psychological effect of knowing that other worlds are within reach would be immense, fostering a sense of shared destiny and boundless possibility. The arrival of warp drive would physically reshape our planet. Airports, the great hubs of the 20th and 21st centuries, would either evolve or become relics. Major coastal cities, like New York, Shanghai, London, might see their familiar airports retrofitted into hybrid spaceports. Sleek, atmospheric-to-orbit shuttles launching from reinforced runways. But the real action would happen elsewhere. The immense energy requirements and safety considerations of warp launches would likely push the primary spaceports to remote, sparsely populated areas. Nevada, Australian outback. The Gobi, vast stretches of desert, would suddenly become the most valuable real estate on the planet. New cities would sprout from the dust around these hubs. These port towns would be the boom towns of the 21st century, drawing engineers, technicians, cargo handlers, entrepreneurs. Their skylines would be dominated not by skyscrapers, but by massive assembly buildings, control towers, shimmering containment fields over launch pads. These cities would be melting pots of culture, driven to be humanity's gateway to the stars. They would be places of incredible innovation, but also potential social friction as old communities grapple with influx and industry. The architecture of our existing cities would change too. Off-world resources could make building materials cheaper and more exotic. Structures from lightweight, super-strong asteroid alloys. Buildings taller, lighter, and far more energy efficient than today. Urban design must account for a new kind of traffic. Personal and commercial shuttlecraft between rooftops and orbital stations. The skies above our cities, once the domain of birds and airplanes, could become multi-layered highways of silent electric vehicles. But the change would not just be on land. Our oceans could see a resurgence in importance. Floating platforms far from coasts as isolated launch sites for warp-capable vessels. Massive mobile spaceports repositioned for weather or geopolitics. Self-sustaining cities at sea, powered by ocean thermal energy conversion, home to thousands. The deep oceans would become linked to our first steps into space, connecting blue with black. It's a lot to take in. With great speed comes great responsibility. A warp-capable world is a far more interconnected and potentially volatile place. The ability to cross the solar system in days means that events on Mars or a mining colony in the asteroid belt could have immediate consequences for Earth. A disease outbreak on a distant outpost could reach a terrestrial city before we even knew it existed. A political dispute on a lunar settlement could escalate into a crisis that requires a rapid response from a terrestrial government. We would need a new framework for global, or rather systemic, governance. Diplomacy would have to operate at warp speed as well. The United Nations might evolve into the United Planets, a body tasked with creating and enforcing laws for space. Who gets to claim a mineral-rich asteroid? What are the traffic laws for the route between Earth and Jupiter? Who is liable if a warp drive malfunction causes damage? These questions would need answers, and fast. The first treaties would likely focus on safety protocols, shared navigation, data rescue operations. But soon, harder issues like resource rights, territorial claims, the demilitarization of space would dominate the agenda. The technology would also create new potential for conflict. A nation with a fleet of warp ships would have an unprecedented military advantage. The ability to position assets anywhere in the solar system almost instantly would render most conventional defenses obsolete. This could lead to a tense standoff, a new kind of Cold War where the high ground is not just orbit, but the entire solar system. The temptation to weaponize the technology would be immense. For the sake of survival, humanity would be forced to forge new international agreements based on transparency and mutual verification, perhaps with a global agency monitoring all warp travel to prevent misuse. The scientific implications of warp drive are almost too vast to comprehend. It would be like giving Galileo not just a better telescope, but a spaceship. Astronomy would transform from a passive act of observation into an active experimental science. We could send probes to fly through the rings of Saturn, dive into the great red spot of Jupiter, land on the icy shores of Pluto's heart-shaped plains. We could place telescopes on the far side of the moon, free from Earth's radio noise, or build a truly colossal interferometer using detectors spread across the entire solar system. The biggest scientific question of all: are we alone? Warp drive would give us the tools to finally answer it. Instead of just listening for signals, we could go and look. Robotic probes could be dispatched to the most promising nearby exoplanets. TRAPPIST-1, Proxima Centauri. They could analyze atmospheres for biosignatures, scan surfaces for signs of vegetation, and collect samples from alien oceans. The discovery of even microbial life on another world would be a watershed moment. It would fundamentally change our understanding of our own existence and our place in the universe. Even if we don't find life, the discoveries would be profound. We would learn about planetary formation by studying thousands of worlds up close. We would unlock the secrets of stars by sampling their stellar winds. We would test the limits of physics by observing warped space near black holes and neutron stars from a safe distance. Every mission would return a fire hose of data, fueling decades of research and inspiring a new generation of scientists. Entirely new fields of study would emerge: exogeology, astrobiology, stellar engineering. Knowledge would accumulate at an exponential rate. This explosion of knowledge would hold up a mirror to ourselves, learning about the vast diversity of worlds: barren, toxic, frozen, teeming with life. Seeing how easily a planet can become an uninhabitable wasteland like Venus or a frozen desert like Mars would underscore the preciousness and fragility of Earth's biosphere. The exploration of space might trigger the greatest environmental movement in history. Of all the worlds we visit, there is truly no place like home. The stars would teach us about ourselves. Beyond the grand sweep of politics and science, the arrival of warp drive would reshape the intimate details of human lives. It would change our careers, it would change our families, it would change our deepest hopes and fears. The job market would undergo a seismic shift. Warp field technicians, asteroid prospectors, exoplanet cartographers, zero-G construction workers, interstellar tour guides. Some traditional jobs in long-haul transport and resource extraction might decline. Governments and educational institutions would scramble to create retraining programs. The structure of the family itself could change. With travel times drastically reduced, living on different celestial bodies would become a viable lifestyle. A child might grow up on a Martian colony while video calling their grandparents back on Earth every day. Long-distance relationships could span millions of miles, because a physical reunion could be a short trip away. New cultural identities could emerge: lunar or Martian first, terrestrial nationality second. New traditions and rites of passage would appear. The first baby born on Titan. The anniversary of a colony's founding. Many would worry about being left behind in the new economy. Others would fear losing cultural identity in a hyper-connected system. There would be a note of sadness. the end of an era when humanity lived on one world. What does it do to the mind to see Earth shrink to a tiny blue dot? How do we cope with the loneliness of a small outpost on a silent moon? Art and culture would rush to make sense of it all. Epic tales of exploration and discovery. Quiet, personal stories about love and loss across the void. Film, literature, music. Artists inspired by an alien sunset. Artists inspired by a gas giant's cloud patterns. Philosophers and theologians would grapple with the implications of finding, or not finding, life elsewhere. The warp drive would become a muse, forcing new questions about what it means to be human in a vastly expanded universe. The most critical question in a post-warp world is one of control. A technology this transformative is also a technology of immense power. Who gets to build it? Who gets to use it? And who sets the rules? In the early days, the technology would likely be held by a handful of entities, a few national governments, powerful private corporations. This would create an immediate and dramatic imbalance of power. These groups could control access to the riches of the solar system, creating a new form of technological feudalism, where the warp haves dominate the warp have-nots. The potential for inequality is enormous. If trips to orbital habitats or lunar resorts are only affordable for the ultra-wealthy, it could create a literal upper class that lives above the rest of the world. The first benefits of off-world resources might flow only to the shareholders of the corporations that mine them, widening the gap between rich and poor. This could lead to widespread social unrest and a powerful political backlash against the space barons. The central challenge for humanity would be to ensure that the benefits of this technology are shared broadly, lifting all of humanity, not just a privileged few. This struggle for control would play out in the halls of government and on the world stage. Populist leaders might call for nationalization. Tech billionaires might argue private innovation. A global debate would rage. Should warp drive be a public utility, like water or electricity, accessible to all? Or a commercial enterprise, driven by competition and profit? The answer we choose would define the character of our interstellar future. It would determine whether space becomes a frontier for all, or a playground for the powerful. Ultimately, the best hope lies in a robust, independent international body. An interstellar transit authority could license the technology, manage space traffic, and ensure fair access. It could collect royalties on off-world mining to fund social programs, turning cosmic wealth into a universal dividend. This would not be easy. Nations would need to cede some sovereignty for the common good. The alternative, a chaotic, unregulated gold rush in space, is far more dangerous. The choice, cooperation or chaos. So we stand on the precipice of this incredible future. The year is 2030 and the stars are suddenly within our grasp. We have seen how a warp drive could remake our world, shrinking distances, creating new economies, reshaping our cities, expanding our minds. It would be an age of unprecedented opportunity and unnerving risk. It would bring us face to face with the best and worst of our own nature. Our curiosity, our greed, our capacity for unity, our tendency toward conflict. The arrival of warp drive would not solve our problems. It would magnify them on a cosmic scale. This journey forces us to reflect. For all its technological marvel, the true challenge of the warp drive is not one of physics or engineering. It is a challenge of ethics, wisdom, and foresight. Having the power to go anywhere is not the same as having the wisdom to know where we should go and how we should behave when we arrive. We would be the custodians of new worlds. Would we protect them, as we have slowly learned to protect our own? Or would we exploit them, repeating the mistakes of our past on a planetary scale? The technology gives us a choice. We must prepare now. We should be fostering a global conversation about the ethics of space exploration. We should be investing in collaborative international science that builds trust between nations. We should be teaching our children not just science and math, but also empathy and a sense of global and cosmic citizenship. The future is not something that happens to us. It is something we build. By thinking about these challenges today, we can be better prepared to meet them tomorrow, whether a warp drive arrives in 2030 or 2300. Imagine, one last time, that child looking up at the night sky. The stars are blinking. For all of human history, that sky has been a beautiful painted ceiling. The warp drive would shatter that ceiling, turning it into an open door. It would hand us a universe of infinite possibilities. The story of what happens next is not yet written. It would be our story to write. And so, we are left with the most important question of all, one that has nothing to do with technology and everything to do with us. Are we ready?